Hello, this video was created by the Purdue College of Technology at New Albany in our class MET 346 Materials 2. This is by Isaac Blackman, Hunter Stephenson, and Adam Harbeson. Alpha region, eutectic point, solidus line, beta plus liquid region. What are all these? These questions will be answered shortly, but one thing that we can't help you with is that your professor has a thick Russian accent. So this is a really complicated looking iron-carbon phase diagram. It has many different regions on it. We have eutectic points, eutectoid points, per-eutectoids, and per-eutectics. And it's a lot to understand until we break it down and go back to the basics. There's a lot to understand on a phase diagram, but we're going to start. So this is a basic phase diagram. We have 6 different regions on it. We have a solid region, a liquid region, an alpha region, a beta region, an alpha plus liquid region, a beta plus liquid region, and 2 important lines, the solidus line and the liquidus line, and one very important point, which is the eutectic point. Now that eutectic point may be later called a eutectoid or a per-eutectoid or a per-eutectic, and they have different meanings, but in this case it is definitely called a eutectic point, and our other classmates will cover the different types of points on those. Also down at the bottom we have the composition in percent weight of the silver as you move across the type of material, how much silver is actually in it. And we're going to be focusing on just the alpha plus liquid region and the beta plus liquid region, these two. Moving forward, we can use this table at the bottom of the screen to help better organize our data. We have on the far left corner temperature and percent silver that can give us basis to go off of. So at a certain temperature that it has been annealed from and a percent silver, we can start right here with 20% silver. This is just an example. 20% silver and 900 degrees Celsius for the temperature. And at this point, we can make a dot right here as our reference point, and that lies right inside of the alpha plus liquid region. So we can easily drop in the temperature at 900 degrees Celsius and the percent silver at 20% down in that bottom of the table. So moving forward, we see that there are 2 phases present, the alpha and liquid phase that we've already talked about before as this region. But furthermore, we need to start to figure out, using a tie bar, what the percent copper composition is and the percent liquid is on that area. So we're going to tie on a tie bar, not this kind of tie bar, this kind of tie bar, which is better suited for this task. And if we draw lines down from the top to the bottom, we can see that copper, that the alpha region meets at 7%, and the beta region, or the liquid region actually, meets at 45%. And we can put those in the table below in order to do the calculation that comes next. For the calculation, we have an equation that can lead to figuring out the alpha, the first phase that we list in there. And it's always the first phase using the variables beneath. So if we move these numbers into the equation, we can solve to figure out that our alpha percentage is 65.8%, and the remainder of that, of the 100%, is 34.2% liquid. So moving on, we can look back and we can see we have our 65.8% alpha is the longer line on the tie bar. So why is it the longer line on the tie bar? Because we know that 65.8% is closer to the liquid line. Why is that? Why is the 34.2% liquid? Why is that percent liquid and not percent alpha? So we can move in. We have a great example for that our professor has helped us move into, and we can show you through the idea of running a race. So when you're at the start of a race, you're 0% finished with that race. As you move forward, quarter way through the race, you're 25% finished, and halfway through the race, you're 50% finished. So you're 34.2% finished. We can draw that directly back over to alpha and liquid. If we're 34.2% through that phase, that composition, the alpha plus liquid phase, then we are directly at 34.2% liquid. So if 34.2% of your race is complete, then there's 34.2% liquid in that race. Or in this diagram, this example, 34.2% liquid for the alpha plus liquid region. So moving on, you can kind of see how that 34.2% is actually at that point in the at 20% silver, we are at 34.2% liquid, not 34.2% alpha.
and that's because we're getting closer to the liquid phase. As we move closer and closer to the liquid phase, we're going to have fully 100% liquid. So if you can imagine the dot all the way on the liquidus line, that would be 100% liquid. So moving on, the other special thing about our phase diagrams and these phase diagrams specifically is the flat solidus line. And that's specifically that line all the way across the board at that temperature is where the fluid, whatever it be, maybe it's liquid or it's alpha plus liquid or it's beta plus liquid, becomes a solid, completely solid beneath that line. Moving on, now you can maybe better understand the iron-carbon phase diagram. And it is a very complicated diagram, and it becomes really hard to understand. If you look through all of it, it can look very complicated. But we have a lot of other videos from our other classmates at Purdue who can offer you a little bit more in-depth look at some of the different parts of it rather than just the alpha plus liquid and beta plus liquid regions. So if you look at these, we have them linked in the video. Check them out, and thank you for watching.